Good afternoon, boys and girls. This is Mr. Schleier. We're going to talk a little bit about severe weather, and we're going to start right off with one of these. So, you've seen these before. I've shown you videos of some of these. This is your hurricane. We talked a little bit about hurricanes early in September with Hurricane Dorian. We're going to talk a little bit about Hurricane Dorian in just a minute. But basically, you're looking at a hurricane, and it is simply a low pressure system. You can see the eye of the hurricane. You can see this counterclockwise rotation, and that's basically what your hurricanes are going to look like. Now, we see hurricanes in the summertime. We don't see them in the wintertime because a hurricane needs warm water and warm temperatures. So we always see hurricanes gain strength when they're in the Gulf of Mexico, in the southern part of the Atlantic Ocean, and as they work their way north, they start to die down. Now, when a hurricane makes landfall, that means that the center of the hurricane hits land. Immediately, when that happens, the hurricane wind speed dies down because it has no moisture to draw off of. The eye needs to be over water for a hurricane to gain strength, and once it hits land, it's not going to be over water anymore. It's going to start to die down. Now, cross section of a hurricane looks kind of like this. It is a low pressure system. You have counterclockwise of rotation, and the center of the eye is actually a high pressure area. That high pressure means that there's happy weather in the center. There's no clouds, the winds die down. It looks really nice. The problem is if you go into the center of a hurricane, that means you went through the strongest wind speed right on the eye wall itself. And that means you have to go through it again as the hurricane exits. Hurricanes are categorized by what's called the Saffir-Simpson scale. It's a 5 category scale, one being the weakest hurricane, 5 being the strongest. The strongest hurricanes have wind speeds in excess of 157 miles per hour sustained. That means that the wind continues to blow. It doesn't stop for 157 miles per hour. It is just continuously going. So that's why these types of hurricanes are really dangerous and cause a lot of damage. So when we're talking about Hurricane Dorian was a very large Category 5 hurricane. It lasted for 15 days, and that's kind of unprecedented. We usually see hurricanes only last maybe about 7 to 8 days. This lasted almost a full, a little bit more than 2 weeks. It was incredibly slow moving. It made landfall 6 times and had winds well over 185 miles an hour. So this was a very, very strong hurricane. It really didn't affect us too much. What did affect us was Hurricane Sandy back in 2012. And this was considered a hurricane, but also post tropical because it combined with another low pressure system, which is why Hurricane Sandy was as large as it is. The diameter of Hurricane Sandy from end to end was over 800 miles at one point. It was a massive hurricane, massive size. It only was a Category 1 when it made landfall, but the sheer size of it was really the main problem. Cost the United States over $50 billion worth of damage. Now, this red line is the track that Hurricane Sandy made, and you can see it made this weird left-hand turn. This spaghetti model shows you the path that most hurricanes generally take. You can see that they kind of ride along the east coast of the United States and then back out to sea. Hurricane Sandy didn't do that. So this is one of the reasons why Hurricane Sandy was as devastating as it actually was, because it kind of did something that meteorologists don't really expect a hurricane to do. Um, what we do also see in terms of severe weather, we have what's called lake effect snow. Lake effect snow is when cold, dry air blows over the Great Lakes, picking up the warm, moist air at the surface of the water, and you get a lot of evaporation taking place. That evaporation puts moisture into the atmosphere. When it crosses back over land, it drops that moisture in the form of snow. There are some locations in New York State, like Buffalo and Rochester, that have seen over 53 inches of snowfall in 2 days due to lake effect. So, lake effect more or less happens every winter along the coastline of Lake Erie and the Great Lakes. And there are times where you can get feet's worth of snow in the matter of a couple days. So their lake effect is pretty incredible. We do see lake effect snow down this far, but you do need a really strong low pressure system to do that. What we end up seeing for snow is nor'easters. That's when a continental polar air mass collides with a maritime tropical air mass, and if there's enough cold air, then any precipitation generally will fall as snow. We kind of lucked out in terms of the amount of nor'easters the last couple years. We haven't really seen too many of them, so we haven't really had a lot of those big um, snowstorms. That's because we haven't really seen too many of these storms in the last couple years. What we do see is a lot of thunderstorms, and at any given time, there's about 45 thunderstorms taking place each day across the entire planet. So that's quite a few. Thunderstorms are always associated with a cold front. A warm front gives you long, steady precipitation, generally light, lasts for a day or two. Thunderstorms are very strong and are associated when cold air comes in and forces warm air to rise. So, with thunderstorms, we get lightning. Lightning, to put it really simply, rub your feet on the carpet and touch the door, touch a doorknob, you're going to get zapped. That's lightning. But it's taking place up in the clouds, and it's the air moving up and down causing the static electricity, and eventually that static charge gets discharged and you get lightning. And lightning, we know, is pretty incredible, really cool light show. Tornadoes is probably the worst weather phenomenon that we see. We do get tornadoes here in New York State. They're generally weaker tornadoes, but nonetheless we still see them. So this is when uh, air quickly rises and rotates, always associated with thunderstorms and cold fronts. And some of these tornadoes can have winds in excess of 300 miles per hour. They can be pretty small, couple hundred yards wide, or they can even be close to a mile wide. Those are massive tornadoes. Now, a tornado itself is categorized by the Fujita scale, just like the Saffir-Simpson scale for hurricanes. It's based on wind speed. You have F zeros all the way up to F5s. F5s are very strong tornadoes. Winds can be over 300 miles per hour. Um, and we in New York State will see anywhere between F zeros up to about F2s. So that really does it for severe weather. Make sure that you are watching the videos, you're reading the notes, and hopefully I'll talk to you guys soon. Have a good day.